Hello, this video will be explaining how to analyze gear trains using the equation method. When analyzing gear trains, our aim is to find the output velocity of the system of gears. The equation method is very simple and boils down to these three aims. Firstly, we wish to create expressions for the angular velocities of any gears which have fixed rotation axes. We use the kinematics relationship here, where I is the ith gear and C is the carrier of the system. Secondly, we express the angular velocities in terms of the relative velocity with the carrier. We can treat the carrier as if it is held steady and then develop velocity ratios for each of the relative velocities. This is a large part of the solution for this method. The velocity ratio equation relates the number of teeth between two gears and is constant. This negative sign comes in if the direction of the two gears is opposite. Lastly, to finish off the solution, we use the necessary expressions to then solve for the unknown velocity. Let's take a look at an example. This example is taken from the Engineering Mechanics 2 lecture notes. We have 4 gears and a carrier labeled 3. The fixed shaft is our reference frame, and we have gear 2, which is free to rotate about this fixed shaft. Gear 2 has 20 teeth and an input angular velocity of 250 rpm in the clockwise direction. Gear 4 has 30 teeth and is connected with Gear 2. Gear 4 is also fixed to the carrier 3. However, notice that the carrier 3 can rotate about the fixed shaft. Gear 5, like Gear 4, is fixed to the carrier 3 and it has 16 teeth. Gear 6 has 34 teeth and is connected to Gear 5. However, it is fixed and cannot rotate at all. Thus, the velocity of Gear 6 is 0. We will now create a symbolic diagram for the gear train. The symbolic diagram helps to visualize the problem much more simply. In this system, we are given the angular velocity of Gear 2, thus it is the system input, and we wish to find the angular velocity of the output, which is carrier 3. Here we can note that since gears 4 and 5 are on the same shaft, the angular velocities must be the same. Also remember that gear 6 is fixed. Using the kinematics relationship, we can start substituting the angular velocities for gear 6 and the angular velocity for gear 2. Both of these are knowns. Thus, we can get an expression for the relative angular velocities with respect to gear 3. We could call these equations 1 and equations 2. We can now imagine that the carrier is stationary and start to develop on the relative velocities using velocity ratios. This is because we are taking the angular velocities in respect to the carrier. Two gears within a gear train are related by the multiple velocity ratios that run through the train of gears. This allows us to cancel out the number of teeth and the diameter of the central gears. Thus, you can multiply out the velocity ratios of the central gears to work out a relationship between the two gears in question. Since the angular velocities of gear 4 and 5 are the same, this ratio would just tend to 1. Substituting the number of teeth then into the velocity ratios, we can get a simple value for the relationship between gear 6 and gear 2. Using this value and substituting equations 1 and 2, we can now get an expression in terms of the angular velocity of gear 3. This is because the angular velocities for gear 6 and 2 is known. Since gear 6 is fixed, its angular velocity is 0. And the angular velocity 2 is the input velocity, which is 250 rpm in the clockwise direction. Using the right-hand rule for the sign convention, that means it is in the negative direction. Thus, we can now just solve for the angular velocity of gear 3 to finish off the solution. Thank you for watching.